A great philosopher once said that we are all connected to each other biologically, to the earth chemically, to the universe atomically. And that philosopher was Neil deGrasse Tyson. One such connection is the common ground we share with Mars. The compounds methane and water. You might be asking, how do these two compounds equal life on an otherwise barren planet? That's a great question. Methane is important because on Earth, methane is most commonly found where life is. One such place you can find methane on Earth is in landfills, sewage, and livestock waste. Methane is created by an anaerobic microbe called methanogen, which breaks down carbon dioxide, leaving the byproduct methane. In 2019, the rover Curiosity found methane on Mars, which is significant given methane is broken down quickly by the sun, indicating that the emission was recent. Another essential element of life is water. Water. Water is important because it provides the mineral-rich environment for microbes and eventually organic molecules to thrive. The hydrogen bonds in H2O allow water to trap heat better than other substances, allow surface tension, and make a great solvent. Compared to Earth, Mars' track record with water looks pretty bleak. Mars is smaller, drier, and lacks the shifting tectonic plates that, on Earth, bring in fresh minerals through cracks in the planet's crust. However, the following data indicates the potential of life on Mars. In 2018, Italian scientists working on the European Space Agency's Mars Express mission found a 12-mile underground salty lake residing beneath an ice cap on Mars, near the Martian South Pole. Bodies of water resembling these conditions in Antarctica and Greenland show that if one drills deep enough, one can find microbes adapted to their cold underground environmental conditions. Via either A. Going into a state of suspended animation or slowing their metabolism to deal with low food source. B. Feeding on the minerals rocks provide. Or C. Feeding on sulfur compounds, sulfates, and excreting hydrogen sulfide. So, what kind of life would we find on Mars if methane and water are indeed viable? It's difficult to say, given the randomness of nature. Who's to say Mars won't develop organic bacteria that just hang out there until humans don't exist to wonder anymore? However, just in case you came here hoping that there'd be mention of plants and animals on Mars, here's what any life would have to withstand. Life would have to witness with incredible lung filtration capacity, a tolerance for extreme cold, and the ability to migrate, hibernate, or suspend animation. Any life would also be comparatively much weaker than the flora and fauna of Earth due to the following. A. Mars is a consistently cold, dusty planet with air 50 times thinner than the peak of Mount Everest, making it difficult for the atmosphere to heat. B. Mars is only slightly bigger than half the size of Earth. This means it has lesser gravitational pull. The latter is only 38% of Earth's gravity. Half the year, the sun facing half of the planet experiences summer and spring, and the cold, dark equivalent experiences a long fall and winter. The temperature of Mars reaches a maximum of 70 degrees Fahrenheit, negative 225 degrees at lowest, and negative 81 degrees on average. So, what does this mean? With the data that we gathered, we can conclude that Mars might have the potential for the basic building blocks of life. However, Mars is still missing a couple advantages Earth has, such as a hospitable atmosphere and temperature, in addition to dynamic tectonic plates.